Alright, so this is a continuation of section 1.5 notes. And so we had finished this first critical value problem, or this breakpoint problem. We're going to look at this one. So once again, you start by factoring. So we're going to factor this one by grouping. So you have to group the first two and the last two. So we're going to factor by grouping, and we end up with x squared minus 4 and x plus 3. And then we can factor the x squared minus 4 into x plus 2 and x minus 2. So our breakpoints are going to end up being positive 2, negative 2, and negative 3. So again, we put those breakpoints on our graph. Okay? And then we're going to test areas surrounding those breakpoints. So we're going to test below negative 4. We're going to test between negative 3 and negative 2. Then we're going to test between negative 2 and positive 2, and then we're going to test greater than 2. So when I test negative 4 minus 2 is negative 6. So that's a negative number. And then I test negative 4 here. Negative 2 plus 2 is negative 2. That's a negative number. Then I test negative 4 in here. Negative 4 plus 3 is negative 1. That's a negative number. So negative times negative times negative is negative. So this area of the graph is all negative. So now I'm going to test negative 2.5. So negative 2.5 minus 2 is negative. Negative 2.5 plus 2 is negative 1/2. And negative 2.5 plus 3 is positive. So negative times negative times positive is positive. So this area of the graph is positive. Then we're going to check 0. So this would be negative. This would be positive. This would be positive. So this area of the graph is negative. And then we're going to test 3. So it would be positive, positive, and positive, which is positive. So the areas should alternate. We have negative, positive, negative, positive. And they should alternate. If they don't, there's a chance you might have messed something up. So we want the areas that are greater than 0. So the areas that are greater than 0 are between negative 3 and negative 2. And all of this area over here that's greater than 2. So in interval notation, we write negative 3 to negative 2, union 2 to infinity. And so the answer to the solution would be that. Okay, another one. So again, we start by factoring. So our breakpoints are positive 5 and negative 3. So we divide our number line at positive 5 and negative 3. And then we're testing the values to the left, in the middle, and to the right. So the values to the left, I'm using negative 4. So I end up with negative and negative, which is all positive. Negative times negative is positive. Then I test 0. I get negative and positive, which is negative. Negative times positive is negative. And then I test 6, which is positive and positive. Positive times positive is positive. So we care about, again, the areas that are greater than 0, which are over here and over here. So we write that as negative infinity to negative 3, union 5 to infinity. All right, so then we get into our next type of problem. And these are breakpoints, but they're rational inequalities. So the most common mistake people want to do is they want to cross multiply, and you can't. You cannot cross multiply. So you have to start this by getting everything set to 0. So you've got to set it less than or equal to 0. And this time our breakpoints are going to be the numerator and the denominator. So let's see what happens. When I move that 2 over, I end up with 3x plus 4 over x plus 1 minus 2 is less than 0. So I have to have a common denominator. So to get a common denominator, I'm going to take whatever the denominator is here and put it with the 2. So I'm going to get 3x plus 4 over x plus 1 minus 2 x plus 1 over x plus 1. So this is how I get my common denominator. So now that leads to this step right here, where I have everything over the same denominator, and I have to distribute. So I end up with 3x plus 4 minus 2x minus 2 all over x plus 1. Sorry, I left out a step. And then I combine like terms, and I end up with x plus 2 over x plus 1 is less than or equal to 0. So my breakpoints are going to be the numerator and denominator. So the breakpoints are -2 and -1. So here are my breakpoints on my number line. And again, I'm going to test to the left of -2 and between and to the right. So when I test it, I'm testing it in this fraction. So -3 plus 2 is negative. -3 plus 1 is negative. And negative divided by negative is positive. Then I test this one. -1.5 plus 2 is positive. -1.5 plus 1 is negative. Positive divided by negative is negative. And then I test in here. I'm going to test 0. So 0 plus 2 is positive. 0 plus 1 is positive. Positive divided by positive is positive. So I want the values that are less than 0, which are the negatives. So I want all this area between -2 and -1. So I would be inclined to write -2, -1 with brackets because it's less than or equal to. But you have to remember all the way back up here, x cannot equal -1, right? We have to restrict our domain. So that means we have to put our parenthesis on the -1. Okay, so let's look at this next one. So we're moving the -3. We get our common denominator, so we put x minus 3 next to the -3. We distribute, so you get -3x plus 9. And then the 9s are going to cancel out. You're left with 2x on top and x minus 3 on the bottom. All of this is greater than or equal to 0. So my breakpoints this time are going to be 0 and 3. So here are my breakpoints on my number line, 0 and 3. And I'm going to test -1, +1, and 4. When I test -1 here, I get a negative on top, and I get a negative on the bottom. Negative times negative divided by negative is positive. When I test 1, I get a positive on top and a negative on the bottom. Positive divided by negative is negative. And when I test 4, I get a positive on top and a positive on the bottom. Positive divided by positive is positive. So this time I want the positive areas of the graph, which are over here and over here. So my answer is going to be from -infinity to 0, and then from 3 to +infinity. It is greater than or equal to, so that means x cannot equal 3. So I have to have a parenthesis here, but I'm going to have a square bracket right there. Okay, hope this helps.